Hurricanes. Intense or violent depressions are known to most of us as hurricanes, though they have different names depending on the area over which they form. In the Atlantic and Eastern Pacific, the familiar term is used, however. In the Western Pacific, these weather systems are more commonly referred to as typhoons, and in the Indian Ocean, they are given yet another name, cyclones. But by whatever name they are known, all hurricanes essentially begin life the same way, as strong clusters of thunderstorms. These thunderstorms sometimes make their way out to sea, and when they drift over warm ocean waters, they can start to pick up intensity at a remarkable rate. The warm air from the storm cluster combines with the warm air at the ocean surface and starts to rise. This creates low pressure at the surface. Trade winds, blowing in opposite directions, then cause the storm cluster to start spinning. And the rising warm air causes pressure to decrease at higher altitudes. The warm air rises faster and faster to fill the low pressure, in turn drawing more warm air off the ocean surface and sucking cooler, drier air downwards. As the storm travels over the ocean, it starts to pick up more warm, moist air, and wind speeds accelerate as more and more air is being sucked into the low-pressure center. A fully deformed storm can take anything from several hours to a few days to form and is comprised of an eye of calm wind and low pressure at the center, surrounded by a spinning vortex of high winds and intense rainstorms. The Saffir-Simpson scale is used to categorize hurricanes, especially in the Americas and increasingly throughout the rest of the world. Category 1 storms are the weakest, registering wind speeds of 74 to 95 miles per hour. These systems are unlikely to cause serious damage or widespread flooding, producing a storm surge of just 1.2 to 1.5 meters above normal. Category 2 storms have slightly more serious implications. Wind speeds can range from 96 to 110 miles per hour, strong enough to cause slight damage to roofs as well as compromising the integrity of weaker trees and building structures. The storm surge produced is about 1.8 to 2.4 meters, which is still not enough to cause any major flooding. Category 3 hurricanes are much more problematic and produce wind speeds 111 to 130 miles per hour, capable of causing more serious damage to building structures in general and localized severe flooding, with a storm surge of 2.7 to 3.7 meters. Category 4 systems are extremely dangerous and pose a serious threat to human life. Wind speeds of 131 to 151 miles per hour destroy whole roofs and cause major structural damage to entire buildings. A storm surge of 4 to 5.5 meters increases the likelihood of more widespread flooding too. The largest storms, Category 5, can bring devastation and pose an immediate threat to human life where they make landfall. Winds speeds upwards of 151 miles per hour have the capacity to raise entire buildings. A storm surge of 5.5 meters or more is typically produced. Not only is there localized flooding in the immediate vicinity of the location where the hurricane makes landfall, there is also widespread, serious flooding further inland. Hurricane Danny is a Category 1 storm, which made landfall near Lake Charles, Louisiana in 1985. As it tracked across the Atlantic towards America, the system appeared to pose little threat until it suddenly intensified into a tropical storm and then a hurricane in the space of 24 hours on the 14th of August that year. Danny's wind speeds were not significant enough to pose a serious threat when the storm made landfall, and it quickly weakened into a tropical depression again. The real danger posed by systems of this kind is the potential for heavy rainfall. Danny dropped 3 inches over Louisiana in the space of a few hours. The other major risk factor is the threat of tornadoes spouting. Danny produced 14 tornadoes, a record for any hurricane at that time, which were responsible for several fatalities and caused over $100 million worth of damage. Hurricane Andrew was a Category 5 storm at the other end of the scale, which struck the Florida coast on August 24, 1992. Unlike Danny and most hurricanes, the storm system was directly responsible for causing widespread damage. It was the intensity of the winds rather than the volume of rainfall, flooding, or offshoot tornadoes which wreaked the most havoc. Peak wind speeds of 165 miles per hour flattened out buildings and prefabricated houses and leveled entire neighborhoods across Miami. 25% of the trees in the Florida Everglades were knocked down in the storm, and upwards of $26 billion of damage was caused, making it the second costliest hurricane in U.S. history. Every intense depression brings its own unique set of challenges. Hurricane Katrina, which made landfall in Louisiana in the summer of 2005, was the costliest and one of the deadliest storms in American history, yet it was only a Category 3 event when it struck New Orleans. Katrina illustrates that it is not just the intensity of the storm which determines its capacity for destruction, but also other factors such as the preparedness of the people in its path and the geographic features of the land, height above sea level, etc.